Welcome to the lesson, Interpreting Findings. In this lesson, you will distinguish what characterizes science, scientific thinking, and scientific explanations, and you will learn to differentiate between science and pseudoscience. Surgeons use special precautions before they can treat people. These measures are taken to prevent infections. The need for special conditions in an operating room was realized mainly through the pioneering work of Dr. Joseph Lister, 1827 to 1912. Click the images to learn more. Dr. Lister, along with other surgeons, was concerned with wound infections that claimed many lives. Until Lister's studies, people thought that exposure to bad air was responsible for these infections. Dr. Lister noticed that more midwife-delivered babies survived than surgeon-delivered babies. He attributed this to the fact that midwives wash their hands before delivering a baby. In 1865, Louis Pasteur described the role of living microorganisms in the air, and Lister made the connection with wound infections. Lister understood the importance of sterilization and disinfection. He introduced the use of gloves and sterilization in operating rooms. Look at this modern operating room. Everything here is sterile. Lister's principles of antiseptic surgery are strictly implemented here. John Lister's story is science at its best. Science is the exploration of the physical world based on empirical evidence and logical reasoning. Empirical evidence is the data collected through experimentation and careful observations. Let's look at some aspects of science. Which of the following statements are true? Click your answer. Choose all that apply. Not quite. Scientists arrive at their explanations through logical deductions relying on empirical evidence. More evidence makes a scientific claim more valid. Claims that are not based on empirical evidence or logical reasoning are unscientific. Sometimes they are called pseudoscience. Some of the explanations for natural phenomena we now accept as facts were previously interpreted differently. Click the images to learn more. The following phenomenon is a spectacular one that intrigued generations of humans. Let's take a look at how comets have been interpreted throughout history. Comets are seen occasionally in the sky. They are characterized by a glowing tail. Comets stirred all kinds of emotions and had supernatural explanations. People interpreted their appearance as a warning that the end of the world might be near. Eventually, a scientific explanation was found. It followed Isaac Newton's explanation of planetary motion around the sun. In 1705, astronomer Edmund Halley, Newton's friend, hypothesized that comets orbit around the sun in the same manner planets do. According to Halley's hypothesis, comets spend a short amount of time near the sun where they warm up and glow. Then they disappear from sight and reappear at a later time. Sometimes we wait for many years to see them again. How could Halley support his hypothesis? Halley went through records of astronomical events and found evidence that a comet appeared 3 times with a time interval of about 75 years between each appearance. If it was the same comet, its next arrival had to occur 75 years after its last appearance. Indeed, this was confirmed after Halley's death. The comet was named after him, Halley's Comet. Now the phenomenon is explained scientifically. In this activity, you will explore the orbits of different objects around the sun. You'll use your observations to identify which object is Halley's Comet. Here's what you'll use. A model of the sun, Earth, and other objects. You can see the sun in the center with Earth in orbit around it. You'll select one of 4 other objects to orbit the Sun. You'll see a trace of each object's orbit. A time recorder. You'll measure the time it takes each object to complete an orbit around the Sun. This is the object's orbital period. A data table. You'll record each object's orbital period and shape in the table. How will you determine which object in the model is Halley's Comet? Remember that part of the orbit must be close enough to the Sun for the comet to glow. This tells us something important about the shape of the comet's orbit. Remember that the period of Halley's Comet is about 75 years. Enter your prediction and click OK.
Continue to see if your prediction is correct.
Make a plan. How will you investigate each object in the model to determine which one is Halley's Comet? Type your plan and click OK. Check your plan. Did you set a goal and include these steps? Observe the first object's orbit. Note how long it took for this object to orbit the Sun. Record both the number of years and the shape of the orbit in the table. Repeat this process for each object. If your plan does not include these steps, you can change it. Once you've finished, click the next button to move on. Now follow your plan to investigate the orbits of 4 different objects. Select an object to view. Click the Run button. The simulation will stop when the object has completed 1 revolution around the Sun. How many years did it take the object to complete an orbit? Was the orbit more circular or elliptical? Record the orbital period and shape. Click the Reset button and repeat these steps for the other objects. Look at your data of the simulated orbits. Can you tell which orbit represents Halley's Comet? Explain your answer. The orbital period of Halley's Comet is approximately 75 years. Its orbit must be far from circular so that part of the orbit can be close enough to the Sun to make the comet glow. Object 3 has a non-circular orbit with a period of 75 years, so it represents Halley's Comet. How does your conclusion compare to how scientists explain this? When orbiting the Sun, a comet does not move at a constant speed. Where in its orbit is the comet moving the fastest? Click the Run button and observe the comet. Where in its orbit is the comet moving fastest? Type your answer and click OK. The comet moves fastest when it is closest to the Sun. Because it is moving quickly, the comet is close to the Sun for a very short period of time, and it glows for a very short period of time relative to the time of one complete period. You've learned a lot about interpreting scientific findings. Before we finish, let's take a quick look at the main points you covered. Science seeks to explain the physical world by gathering and analyzing empirical evidence. Scientists arrive at their explanations through logical deductions, relying on empirical evidence. Scientists use imagination in devising hypotheses, predictions, explanations, and models. Now that you've finished the lesson, click the Lab Report button to save or print it.